Imagine a formidable rock mountain. Buried 60 meters beneath its surface lies a secret city. Its walls aren't just concrete, but a composite layer designed to withstand an apocalypse. This isn't science fiction, friends. This is the reality of Iran's Natanz nuclear facility. The question is simple, yet terrifying. How do you destroy something protected by the very geology of the Earth? Is there anything man-made capable of piercing this natural shield? Throughout military history, humanity has always sought the deepest hiding places. But in the modern era, the concept of safe has completely changed. An ancient fear emerges when we realize there's nowhere left to hide, even under millions of tons of granite. American physics and military technology have created an invisible Grim Reaper. We're talking about a dark shadow in the sky carrying a giant 1,4-ton hammer. This is the eternal battle between spear and shield. Iran built a fortress claimed to be impenetrable, layering their nuclear ambitions with military-grade reinforced concrete. On the other side, American engineers responded with insane kinetic energy calculations. Who would win if conflict erupted today? The sophisticated S-300 air defense system, or a stealth aircraft more expensive than gold? Let's dissect the science behind this attack scenario. Hello, I'm Ethan Walker, and welcome to Weapons Science. Today, we're not just talking about war, but about extreme civil engineering and advanced aerodynamics. We'll dissect the B-2 Spirit, the only aircraft capable of carrying the GBU-57 MOP, the most powerful non-nuclear bomb in history. We'll see how this object pierces the ground like a hot needle through butter. Buckle up, because we're entering the danger zone. First, let's map the targets. The Fordo and Natanz fuel enrichment facilities. These locations weren't chosen randomly. Iranian engineers knew conventional airstrikes wouldn't work. They buried these facilities deep within the mountains, protected by tens of meters of natural rock layers, plus layers of steel fiber reinforced concrete. This is a nightmare for any military planner. Let's talk about the concrete. This isn't the concrete used for your sidewalk. We're talking about ultra-high performance concrete. This mix has compressive strengths up to 20,000 pounds per square inches, 5 times stronger than regular concrete. Its molecular structure is so dense that it's almost waterproof and highly resistant to explosion shock waves. Theoretically, this is a perfect shield. Depth is a key factor. 60 meters. Imagine a 20-story building, but buried underground. Conventional bombs, even 2,000-pounders, would only scratch the surface. Their explosions would spread sideways, not downwards. To reach the core of this facility, we don't need a large surface explosion. We need precise, vertical penetration. We need a giant drill falling from the sky. But before we can drop anything, we have to get there. And that's another big problem. Iran's skies are among the most heavily guarded in the Middle East. They possess Russian-made S-300 PMU-2 systems and locally made Bavar 373 systems. These radars sweep the skies 24 hours a day, searching for the slightest anomaly. Regular fighter jets like F-15S or F-16S would be detected hundreds of kilometers before reaching the border. Simply put, radar emits radio waves. If those waves hit a metal object, they bounce back to the receiver. The larger and more perpendicular the object's surface, the stronger the reflection. Conventional aircraft are excellent radar reflectors because they have many right angles, exposed engines, and external weapon pylons. On radar screens, they shine like spotlights in a dark room. The S-300 system has a detection range of up to 250 kilometers and can shoot down targets at 150 kilometers. Its missiles fly at hypersonic speeds, Mach 6. For ordinary pilots, entering this zone is a suicide mission. So, how can America deliver a 1,4-ton package into the heart of this hornet's nest? The answer was born from the Cold War, the Northrop Grumman B-2 Spirit. Look at its shape. No vertical tail, no tubular fuselage, no sharp angles. This is a pure flying wing design. This shape isn't for style, friends. Every curve, every angle was calculated with supercomputers to reflect radar waves in another direction away from their source. The main principle is deflection. When enemy radar waves hit the B-2, its flattened shape makes the waves slide off like water poured onto a tilted flat plate. Almost no energy returns to the enemy radar. Plus, its engines are deeply embedded. But shape alone isn't enough. The B-2 is coated with a secret material called radar-absorbent material. Its chemical composition is a closely guarded state secret, but its principle is similar to a black sponge absorbing light. RAM absorbs radio wave energy and converts it into a small amount of heat instead of reflecting it. The result? On enemy radar screens, this giant aircraft with a 5.2-meter wingspan appears the size of a small bird or insect. Stealth isn't just about radar. Heat-seeking missiles are also a threat. The B-2 overcomes this with a unique exhaust system. Hot gases from the engines are mixed with cool air before being expelled through flat slots on the top of the wings, not the rear. The rear wing sections are coated with heat-resistant ceramics to hide infrared traces from ground sensors. It truly is a ghost in the night. This technology comes with a fantastic price tag. One B-2 Spirit unit is worth about $2 billion US. That's equivalent to the GDP of several small countries. America only has 20 operational units. Losing even one would be a strategic disaster, but only this aircraft can carry the special package we discussed earlier into the heart of Iran's defenses undetected. Now, let's talk about the weapon. During the 1991 Gulf War, America realized they had no bomb that could penetrate deep Iraqi command bunkers. In a panic, they created the GBU-58 from an old artillery barrel in less than a month. But the GBU-58 weighed only 5,000 pounds. For a target like modern Natanz, that's like throwing a pebble at a steel door. This is the real monster, the GBU-57 Massive Ordnance Penetrator, or MOP. It's 6 meters long, weighing 13.6 tons. Imagine a school bus compressed into a solid steel cylinder, then dropped from 30,000 feet. This isn't just a bomb. It's a giant kinetic projectile carrying high explosives inside. The secret to the GBU-57 isn't just its explosion, but its casing. Most of its 1.4-ton weight is metal, not explosive. It's made from a special alloy steel, likely tungsten or Eglin steel, designed not to break upon impact with concrete at supersonic speeds. If its skin breaks on impact, the bomb fails completely. Inside that thick shell, there's only about 2,400 kilograms of PBXN 114 explosive. The ratio of metal weight to explosive is very high, about 80% metal and 20% explosive. Why? Because the GBU-57's main job is to survive its journey through 60 meters of earth and rock. The explosion is just the finishing touch once it reaches the enemy bunker's living room. Let's calculate the physics. When dropped from operational altitude, the GBU-57 accelerates thanks to gravity, reaching near sonic speeds. Upon impact, all the kinetic energy from its 1.4-ton mass, moving at high speed, is focused on one small point at its nose. The resulting pressure reaches millions of pascals. Earth and concrete have no choice but to give way, but the biggest challenge is when to detonate. If it explodes on the first impact, it just creates a surface crater. The GBU-57 uses a smart void sensing fuse. This smart fuse can count the layers it penetrates. It can sense, oh, I just penetrated concrete, now soil, now concrete again. It's programmed to count floors and only detonate after reaching a specified depth. Compare that to a regular bomb. A 2,000-pound Mark 84 bomb would shatter if it hit 3 meters of concrete. The GBU-57? It can penetrate 60 meters of ordinary concrete or 8 meters of super hard reinforced concrete before detonating. This is a terrifying leap in technology. No man-made structure on Earth is truly safe from it if its position is known. Now let's simulate the mission. The most likely scenario is a flight from Whiteman Air Force Base in Missouri, USA, or Diego Garcia in the Indian Ocean. The B-2 Spirit must fly thousands of kilometers. This is no short flight. Pilots must sit in the cramped cockpit for dozens of hours. Mid-air refueling is mandatory, performed in total radio silence. Approaching the Iranian border, full stealth mode is activated, all antennas retracted, radio emissions shut down. The aircraft becomes a black hole in the sky. Below, S-300 radars spin, searching for prey. Radar waves sweep the B-2's body, but nothing returns. Pilots rely on inertial navigation systems and star charts because GPS could be jammed or spoofed in a conflict zone. Above the Natanz target point, the bomb bay doors open. This is the most critical moment because when the doors open, the aircraft's stealth shape is momentarily disrupted. Within seconds, 2 GBU-57s are released. The aircraft's weight drastically reduces by almost 30 tons. The doors close again, and the B-2 immediately turns away. Gravity takes over control of the bombs. The GBU-57 has grid fins at its tail that open to guide its fall using anti-jamming GPS. It corrects its trajectory for a perfectly perpendicular entry angle. The entry angle is vital. If it's slightly angled, the bomb could bounce or break due to lateral pressure. It must enter at an almost 90-degree angle for maximum penetration. Impact. No large fire explosion on the surface, just dust erupting upwards as the Earth swallows 14 tons of steel. Underground, the bomb is swimming through rock. 1 second, 2 seconds. Time seems to slow down. The smart fuse counts the layers. It passes the dining hall, passes the warehouse until it reaches the main centrifuge hall. And then, boom! The explosion occurs within the confined space. The shock wave cannot escape, so it bounces around inside the bunker, multiplying its destructive power. Concrete structures crumble. Sensitive centrifuges become scrap metal in an instant. The bunker roof collapses, burying the facility forever. From outside, the mountain might only tremble like a small earthquake. This attack not only destroys physically, but also psychologically. The message sent is clear: nowhere is safe. However, there's another risk. If the bunker was active, this explosion could trigger a radiation leak trapped underground. This is a double-edged sword. The destruction of military targets could trigger an environmental disaster. The existence of the B-2 and GBU-57 actually serves more as a tool of coercive diplomacy than a weapon of daily war. America wants its enemies to know they have the key to unlock any door. As long as these weapons are in the arsenal, enemies must think twice before burying their facilities deeper. This is a chess game with 1 4-ton pawns. Let's step back a bit. How did such an unusual design like the B-2 come to be? The flying wing concept has existed since the 1940s, pioneered by the Horton brothers in Germany and Jack Northrop in America. But back then, this design was unstable. Without a tail, these aircraft would spin out of control. It wasn't until the advent of digital fly-by-wire computerization that the B-2 could fly straight. The B-2's flight computer makes corrections thousands of times per second. The pilot doesn't directly move the aircraft's control surfaces. The pilot tells the computer where to go, and the computer decides which surfaces move. This makes an aerodynamically unstable aircraft incredibly smooth in the air, a miracle of binary code keeping 170 tons of metal aloft. But the B-2 is a diva in the hangar. Its radar-absorbent coating is very fragile. Exposure to rain, excessive heat, or humidity can damage it. Every time it lands, technicians must inspect every inch of its surface with microscopes. Maintaining this aircraft takes up to 50 human hours of work for every 1 hour of flight. This is why it's rarely flown unless absolutely necessary. Inside the cockpit, there are only 2 people, the pilot and the mission commander. For 40-plus-hour missions to the Middle East and back, they take turns sleeping on small fold-out lounge chairs behind the pilot's seat. They heat food in a small microwave and use a simple chemical toilet. This is an extraordinary test of physical and mental endurance inside a pressurized tube. Back to the GBU-57. Its development was full of challenges. Early tests often failed. The bomb broke upon hitting granite, or its fuse malfunctioned due to extreme vibrations. Boeing had to redesign the steel casing many times. They used supercomputer simulations to model how metal deforms in the first milliseconds of impact. Iran chose the Natanz location because of its geology. The Zagros Mountains consist of hard, sedimentary, and metamorphic rock. This isn't soft clay. To penetrate it, the GBU-57 must be harder than the rock itself. This is why the bomb's nose tip is the most expensive part, a metallurgical masterpiece that must remain sharp despite hitting a mountain. There's another terrifying tactic. The B-2 can drop 2 GBU-57s at the exact same point. The first bomb creates a hole, and the second bomb enters that hole to explode even deeper. This is called mowing the lawn or digging a well. This way, even facilities 100 meters deep can be threatened. Underground explosions have different dynamics. On the surface, energy is lost to the air. Underground, energy becomes seismic waves. It's like a very focused local earthquake. These vibrations can crack concrete foundations, sever electrical cables, and destroy reactor cooling pipes without directly exploding the reactor itself. Are there alternatives? Tomahawk cruise missiles, too small a warhead, tactical nuclear bombs like the B-61-12 could penetrate, but the political and radiation impact is too great. The GBU-57 is the Goldilocks. Powerful enough to destroy, but clean enough not to trigger World War III, it fills a very narrow strategic gap. We're halfway through, we've seen the aircraft, the bomb, and the target. But war isn't just about machines, it's about systems. In this second half, we'll see how satellite intelligence and cyber warfare support this mission. Because without precise coordinates, a 1-4-ton bomb is just an expensive paperweight. How? Spy satellites use synthetic aperture radar 3D. They detect small changes in the ground surface as construction progresses. They also monitor trucks entering and exiting, counting the volume of excavated soil to estimate bunker depth. Remember, a cyber attack can disable air defense radars moments before a physical attack. If the B-2 is the killer, then military hackers are the ones turning off the target's lights before the killer enters. The synergy between cyber and kinetic attacks is the face of modern warfare. Iran, of course, isn't standing still. They are developing smart concrete and blast-resistant doors that can close automatically in milliseconds. They also spread their facilities over a wide area, creating redundancy, so if one is destroyed, others are still operational. This is a very expensive game of cat and mouse. We often forget the human factor. B-2 pilots are the elite of the elite. Their training is brutal. They practice these mission simulations hundreds of times. They memorize every curve of the Zagros Mountains from simulators before seeing the real thing. One small mistake in entering coordinates could mean a bomb falling on a civilian village. Logistics are a nightmare. Sending a B-2 from Missouri to Iran requires a chain of KC-135 and KC-46 tankers waiting at specific points over the Atlantic and Europe. What do you think? Are underground bunkers still relevant in the age of bunker busters level? Or is the best defense to have no target at all? Write your thoughts in the comments below. If you enjoyed this deep dive into military technology, don't forget to hit the like button, subscribe, and turn on notifications so you don't miss our next video on the F-35 or nuclear aircraft carriers. Thank you for watching Weapons Science. I'm Ethan Walker, signing off. Stay curious, and see you in the next video.